Hi, everyone. So today, we have homework due, right? So, yes, go to Blackboard and then click homework. Then you can submit your files there. So remember, you need to use pencil to finish the work first, and then click the solution and use red pen to make corrections. If you correct, make a check mark on that problem, so I know you have checked that problem. Okay? After you finish, take pictures, combine into a PDF, and then upload it in Blackboard. So, yes. Okay, so let's see. Let's continue. So last time we talked about linear equations and we talked about intercepts, right? X-intercepts is where the line crosses the x-axis. So the x-axis corresponds to the y-coordinate is 0, right? So we said the y equals to 0. And then we solve for x. X-intercepts, they are points. Points is the order pair. Right, everybody? It's not an equation. So x equals to a number. This is a vertical line. Okay, this is not a point. Similarly, y-intercepts. We said the x equals to 0 and solve for y. We get a point. X-intercept and y-intercepts, they're points. They're not lines. Okay? X equals to a number is a vertical line. Y equals to a number is a horizontal line. Okay, be careful with that. And then, let's continue. Example 4. Use the graph provided to answer the following questions. Find y when x is 2. Okay? When x, so this is the x-axis. When x is 2, what's the y? 0. Yes. Right? That's 0. So y equals 0. Find the y when x is 0. When x is 0, what's the y? 5, right? Ooh, that's easy. So y equals 5. And then find the y when x is 1. X is 1, like 2.5, right? So 2.5. Find the x when y equals 10. Wow, here in this picture, y is 6 at most. So you want to go beyond that. Okay, make the line longer. Okay? But you can imagine. Here, this is 2, and then this is 5, right? And if you want to find 10. So 10 is like right here. Then the corresponding x is -2. Do you see, everybody? This is kind of like a similar triangle, right? This ratio, 2, and then this is 5. So if you add another 5, well then this horizontal distance must be 2. Therefore, this is -2. Yes, everybody? So x equals -2. Okay, so that is example 4. So I can give you the graph, and then I can give you the x values, ask you to find the y value, or I give you the y value and ask you to find the x values. Right. Okay, and is it raining? Oh, okay. Sketch the graph of y equals to 5. Okay, y equals to 5. So this is x-axis, this is y-axis. This is 0. Y equals to 5. So we go up 5. And y equals to 5 is a horizontal line. Yeah? So y equals 5 is a horizontal line. Okay. And how about x equals -3? So we draw the x-axis and we draw the y-axis. 0 is the origin. X equals negative. So negative is the left hand side, right? Positive is the right hand side. So -3 on the left. -3. And then it is a vertical line. Okay, so this is a vertical line. X equals -3. Okay, so for my requirements, when you draw the graph, for the numbers, please write down the number. You're not required to put the little bars like 1, 2, 3, 4, 5. You don't have to put this bar, okay? But 5, you must put down this important number 5 there. Is that clear, everybody? Mm-hmm. And then here, you don't have to draw those bars. You don't have to. You just put the number there and say this is -3. So please write down -3. If you don't write down the 5 and -3, okay, I don't know. Is it in one bar? Is your unit 1 or your unit is 2? It's not clear, right? So write down the number is more important than mark those bars, okay? All right, so to summarize, the horizontal line passing through the point AB. Okay, let's draw the picture here. Let's say this point is AB. The horizontal line passing through this point, well then, look at this. This is the horizontal line, right? It has the equation y equals b. Yes, everybody? So y equals b. How about the vertical line? What do you say? Yeah, very good. So vertical line here, x equals a. Right? Any questions so far? They're all good? Mm-hmm. All right. Summary. Symmetry. Sorry, symmetry. Graphs of equations can have symmetry with respect to one of the coordinate axes or with respect to the origin. Okay. Graphical test for symmetry. A graph is symmetric with respect to the x-axis if whenever xy is on the graph, x minus y is also on the graph. Okay, look at this picture. All right, look at this picture. So this is the point x comma y, right? And then look at this point. Do you see the x coordinate is the same? Do you see the x coordinate is the same? But the y coordinates, this is y, and then this is below the x-axis, right? So the y is negative. So this is negative y. Okay. So this is symmetric with respect to the x-axis. So this is the x-axis. This is the y-axis. So a graph is symmetric with respect to the x-axis. If xy is on the graph and x comma negative y is also on the graph, right? So you can draw the picture and then you see, oh, these 2 points, they have the same x values, but the y value are opposites, right, everybody? Mm-hmm. Okay, so that's symmetric with respect to the x-axis. How about symmetric with respect to the y-axis? Okay. Let's draw another example. Okay, this is the y-axis. Let's say this point is x comma y. Look at the mirror image right here. Yes, it's like mirror image about the line walk, the y-axis. Here, what is the x? Negative, right? This is the x, and then here is the same distance to the y-axis, but the opposite direction. So this is negative x. And how about the y coordinates? Y. Yes, it's the same height. So therefore, symmetric with respect to the y-axis. If xy is on the graph, negative xy is also on the graph. Right? Okay, how about the next one, the last one? Symmetric with respect to the origin. Okay, so picture looks like this. Okay, this is x, y. Look at So symmetric with respect to the origin means you have this point, right? If you rotate 180 degrees and then you go to the same distance, this point is also on the graph, right? So we rotate 180 degrees, that about the origin. And then this point is also, I don't mean to erase it. Okay, where are we? Right here. Okay, so this point is also on the graph. And look at the x coordinates. This is x. And what's this? Negative x. Right? How about the y coordinates? Negative y, exactly. So this is symmetric with respect to the origin. Right, everybody? Okay, so algebraic test for symmetry. The graph of an equation that is symmetric with respect to the x-axis. When replacing y with negative y, use an equivalence equation. Okay. So you're changing the y to negative y, and you have the equivalence equation. Second, the graph of the equation is symmetric with respect to the y-axis. If replacing x by negative x, use an equivalence equation. Okay? And 3, the graph of the equation is symmetric with respect to the origin. When replacing x with negative x and y with negative y, use an equivalence equation. Okay, everybody? All right. So let's look at the following example. So we want to check whether it's symmetric with respect to the x-axis or y-axis or the origin. Let's check for all three of them. Okay, so symmetric with respect to the x-axis. And then this is symmetric with respect to the y-axis. And then here is symmetric with respect to the origin. Okay, so we check all three of them. Symmetric with respect to the x-axis. We replace, okay, if you kind of forget which one to replace, look at this picture. Symmetric to the x-axis, you have the same x, and the y, you have you can replace y by negative y. Yeah, everybody? So we place y with negative y. And then symmetric with y-axis, symmetric with respect to the y-axis, we we replace the x with negative x. Right, everybody? Look at this picture. Symmetric with respect to the y-axis. The y is the same. The x, we can replace x by negative x. And then origin, do both. So we place y. No, let's do x first. Replace x by or with negative x, and we replace y with negative y. Okay, let's do it. Here, replace y with negative y. So change the y by negative y. Okay, now, are they the same? Are they the same? Are they equivalent? Are they the same? No, they're not the same, right? Therefore, not the same. Therefore, this equation is not symmetric with respect to the x-axis. Okay, how about symmetric with respect to the y-axis? Now we replace x with negative x. Okay, so left-hand side is y. Right-hand side, replace x with negative x. Right? Yeah, everybody? We replace x with negative x. Now, we think, are they equivalent? Can we simplify it? What's minus 1 to the cube? Minus 1 to the cube is still negative 1, right? Oh, we still have y equals negative 2x cubed. Are they the same? No, not the same. Okay, therefore not symmetric with respect to the y-axis. Okay, last one. Replace x with negative x. So the right hand side is 2 negative x cubed. And also replace y with negative y. Yes, everybody? Change y to negative y, change x to negative x. But right hand side, we know that the negative 1 cube is still negative 1. By the way, you don't write something like this. Yes, you don't write something like this. This is multiplication. This is subtraction. So you put the minus sign in front of the 2. Yes, everybody? So we put the minus sign in front of the 2. Oh, do you see we have minus on both sides? We can multiply by minus 1. We get, are they the same? Yes. So it is symmetric with respect to the origin. This equation is symmetric with respect to the origin. Okay, everybody? All right. Okay, so let's continue. Part B. Okay, so part B. Okay, symmetric with respect to the x-axis. Okay, so symmetric with respect to the x-axis. We are replacing y with negative y. Yeah, everybody? So the x stays here. We replace y with negative y. So far, so good, everybody? Okay. Now, what happened? Here, x minus 1 squared. What's minus 1 squared? Minus 1 squared is 1, right? So, we got x minus y squared equals to 1. What happened? Are they the same? Yes. Yes, they are the same. So we get symmetric with respect to the x-axis. Okay? So you can check at home. Okay? You can check at home. It's not symmetric with respect to the y-axis and is not symmetric with respect to the origin. Okay? Right. So our worksheet has a lot of examples. So we might not have time to go over all the examples. So sometimes we go over one type of example and then the extra I'll let you to work at home. Okay. All right. So let's see circles. So as on Wednesday we talk about the geometry and we talk about the equation of the circle. And I also derived with you how do we get the equation of circle by the distance. The point on the circle and the center. The distance is the radius, right? Do you remember that? Yeah, so this is the circle equation. On Wednesday, I said I named the center AB, but here just H and K. So same idea, right? Just different letter for the names. So we have x minus the x coordinate of the center square plus y minus the y coordinate of the center square equals to r squared. And how do we get that? That is the distance between the points on the circle and the center is the radius. And then you square both sides, you get this equation of circle, right? Okay, yeah, so let me draw the picture. So this is the center, H, comma, K, and this is the point on the circle, X, Y. The distance here is the radius, R. Okay, so example 1. The points 3, 4 lies on a circle whose center is negative 1 and 2. write down the standard form of the equation of this circle. Okay, so we have the center. So in order to write the equation of the circle, two things you need. You need to know the center and you need to know the radius. For this problem, we already know the center, right? So we just need to find the radius. How can we find the radius? You have the center and you have a point on the circle, right? So radius is just the distance between them. So we use distance formula. Okay. Do you still remember the distance formula? X2 minus x1 square plus y2 minus y1 square. Yeah, everybody? Okay, so in this case, x2. So you can think of this is like x1, y1, this is x2, y2. x2 is then 2 minus x1, which is 3 square plus y2. Did I make a mistake? Yes, I did. Right? x2 is -1. And now y2 is 2 minus y1 is 4. By the way, you can use this point as x1, y1, and you can use this point as x2, y2. The order does not matter because it's square. Yeah. In this case, -1 minus 3 is -4. But -4 squared, you get what? +4 squared, which is, what's 4 squared? 4 squared. 16, yes. And then 2 minus 4 is -2. -2 squared. 4, yes. 16 plus 4, square root of 20. Yes, everybody? And this distance is actually the radius, right? So therefore, we can use that formula. X minus the x coordinates of the center, which is -1 square, plus y minus k. K is 2. So y minus 2 square equals the square root of 20. This is the r, but we want to do the r square. Yes, everybody? Let's simplify. What is minus -1? Minus negative become plus, yes. And this is y minus 2 square. Do you see square and square root cancel? So you got 20. So this is the equation of the circle. So in exam, you have a problem to ask you to write down the equation of the circle. Okay, so distance formula, the midpoint formula, you gotta remember it. What was the midpoint formula? You have 2 points, x1, y1, x2, y2. The midpoint. Think about average. So the x coordinate is, you add x1 and x2 divided by 2, right? Average. x1 plus x2 divided by 2. And your y coordinates, y1 plus y2 divided by 2. Average, right? This is how you calculate average of two numbers. You add them up and divide it by 2. That will give you the midpoint. Okay, so, all right. Slope of a line. Okay, so consider the line passing through the points x1, y1, and x2, y2. Yeah? And then the slope is rise over run. Okay? Rise. So here, look at this picture. This is change of y, and that is y2 minus y1. And then here is change of x, is x2 minus x1. So rise is like change of y, run is change of x. So therefore we have y2 minus y1 over x2 minus x1. Okay? How many of you have learned slope and lines before? Everybody, right? Okay, so yeah, we can go over quickly. So now slope, usually we call it m for the slope. So now here, so we use the y coordinate of the second point minus the y coordinate of the first point. Yeah. Over what? The x coordinate of the second point minus the x coordinate of the first point. Yes, everybody? Sometimes you can switch the order, but make sure you use y2 minus y1 over x2 minus x1. It's not, don't just flip one of them. Okay, make sure that this is the same point and this is the same point. So minus 1 minus 5 is come from the same point. And then negative 7, negative 2 come from this point. Yeah. Negative 1 minus 7 is negative 8. Denominator 3 and minus 3, right? Negative 5 plus 2 is negative 3. Oh, so the answer is 8 over 3. Yes, everybody? Mm-hmm. Okay, good. And now, if a line slants up from the left to the right, then the slope is, okay, choice. Positive, negative, 0. Which one? If going up, positive, yes, slope is positive. See? Positive. And then look at this picture. If the line slants down from the left to the right, the slope is, what do you say? Negative. If the line is horizontal, parallel to the x-axis, then the slope is 0. Yes. And if the line is vertical, parallel to the x-axis, then the slope is undefined. Right, everybody? Because, okay, you pick 2 points. Do you see they have the same x coordinates? Your slope is change of y over change of x. Your change of x is 0. Can you have 0 in the denominator? Mm-hmm. So therefore, undefined. Yes. Okay, good. Okay, now 2 lines. 2 lines that do not intersect are said to be parallel. Okay, so parallel. What can we say about the slope of 2 parallel lines? The slope are the same. Yes. Right, everybody? Okay, keep going. 2 lines that intersect at a right angle are said to be perpendicular. Okay, perpendicular. Right? Or sometimes we call it normal. Okay. And what can we say about the slope of 2 perpendicular lines? Do you remember the product of the slope of 2 perpendicular lines is, the product of the slope is negative 1. Yes, you remember that? Negative 1. Okay, so if the slope here is m1, this is m2, then m1 times m2 is negative 1. Therefore, M1 is negative 1 over M2. So we say the slope of two perpendicular lines are said to be negative reciprocal. Okay, so negative reciprocal. So far, so good, everybody? Okay. Quick example. If a line has slope 4 over 3, then any line perpendicular to it must have slope negative 3 over 4, right? Yeah, negative reciprocal. So negative 3 over 4. Yes, everybody? Okay. All right. So intercept form. In general, y equals mx plus b is called the slope intercept form of a linear equation. Notice that m gives the slope, yes, and b gives the y-intercept. Okay, the y-intercept, remember they are points. So this is the point 0, comma, b. Okay, the y-intercept is 0, comma, b. Okay, everybody? Yeah. Now find the slope of the line given by the following. So to find the slope, you can get the slope intercept form first. That means, do you notice that your right hand side is the y? Yes, it's y only. We only have one y on the left hand side, right? And then all the x, the constant term is on the right hand side. So in order to get the slope intercept form, you kind of solve for y. Okay, you isolate the y on the left hand side. So we solve for y. Okay, so solve for y. Okay. How do we solve for y? Subtract 3x on both sides, right? So subtract 3x. What do we get? Yeah, very good. And then next, what do we do? Divided by 5 on both sides. So we divided by 5 and divided by 5. What's on your left hand side? Y. What's on your right hand side? Okay, split them. So what is this guy? Yeah, negative 3x over 5. But I want to write it as negative 3 over 5 times x. Because the slope is the coefficient of x. That's why you want to separate the x and then note the coefficient. Would it be x over 5 now? Okay, so negative 3x over 5, right? Then you can move the x outside. If you have negative 3 over 5 and x over 5, this is actually negative 3x over 25. So for one term, so terms are separated by plus or minus. So this is one term. This is another term. When you divide it by 5 on the right-hand side, you divide each term by 5. So that means this term you only divide by a copy of 5, and this term divided by a copy of 5. So, and then negative 3 and x, they are two factors of one term. Okay, yes. Good. Alright, so yeah, so we have the negative 1/5. Right, everybody? So, what is the slope? So, this is the slope. Negative 3 over 5. Yeah, everybody? And the y-intercept is 0, comma negative 1/5. is one way how to graph the slope-intercept form, right? You plot, okay? So using this example, what are we doing? First, plot the y-intercept, which corresponds to the point 0, comma b. So in this example, the y-intercept is 0, negative 1/5. Right, everybody? So 0, negative 1/5. Let's say this is 1. Negative 1/5, let's say, is here. So we're right here. This is 1 point. This is the y-intercept. And then use the slope to get another point. Okay, look at the slope. Slope is rise over 1, negative 3/5. You can think of it as negative 3 over 5. Yeah, because you can put the negative on the numerator or on the denominator, right? Because usually we put on the numerator. And this means we go to the right 5 units. And then right become negative, we go up or down? Down 3 units. Right? So to get another point, we go to the right 5 units. So let's say 1, 2, 3, 4, 5. And then we go down 3 units. 1, 2, 3. Okay, so kind of like that. And then draw the line. Is that okay, everybody? Yeah. So this represents the ratio. So this is the line. Okay. And 2 points can fix a line, right? Okay. Now look at this example. So everybody draw the line. Okay, we're given the slope intercept form. Draw the line. Ooh, good. Got it. Okay. Oh, do you know on our website I have the note with answers? Oh, yes. Oh, okay. Yes. What's the y-intercept? What's the y-intercept? And then to find another point. Mm-hmm. Good. Well done. Oh, yeah. Yes. Okay, so check a word. X-intercept, sorry, y-intercept is 0, negative 2, right here, yeah, everybody? And then slope, is this the slope the same as our last problem? Yes. So we go to the right 5 units, that's the run, 1, 2, 3, 4, 5. And then we go down 3 units, 1, 2, 3. So right here. And then we just connect those points together. So this is the line. Yes, everybody? Okay, good. All right, continue. The point slope of a line. Okay, the point slope form. So we're given last year, given a point on the line and the slope. Then the point slope form is y minus y1 equals m times x minus x1. How do we get that? Okay, that is because how do we compute the slope? Well, slope is change of y over change of x. Okay, so change of y over change of x. And change of y in this case is y minus y1. And change of x in this case is x minus x1. And then you both sides multiply by x minus x1. This is how you get the point of form. Yes, everybody? So this is the point slope form of the linear equation. So point slope form is not unique because if I give you another point on the line, you get a different form. But slope intercept form is unique. So that's why when in the exam or your homework, I ask you to find the equation of the line. I expect you to express your line in the slope intercept form. Is that clear, everybody? You might use the point slope form to write on one form, but at the end, express your answer in slope intercept form. Okay, so here, slope is 3, and we have the points 1, -4. So y minus the y coordinate of the point, which is -4, equals slope. What is slope? Oh, we're using the point slope form. Y minus the y coordinate of the point equals slope. What's slope? 3. And then times x minus 1. Right, everybody? Yes, so make sure you can remember the point slope form. All right. What is minus negative? It becomes positive. So y plus 4 is distribute 3x minus -3. Yes. Okay, solve for y. What do we do? Subtract 4. So y equals, yeah, 3x minus 7. Very good. So I hope you express your final answer like this. Okay? This is a slope intercept one, which is unique. Yes. Any questions so far? No? Okay. Let's see. Can we do this one? Okay. First, we're given 2 points. Can you find the slope? What's your slope? What's your numerator? 4 minus -2. And then the denominator, 1 minus 3. Group. What's 4 minus -2? 6. 1 minus 3. So you get -3. Yes. And you have the slope. Just pick one point. Which point do you pick? 1, 4. Okay, let's do that. So pick 1, 4. Point slope form. Y minus 4 equals -3 times x minus. Good job. So y minus 4 equals -3x plus 3. Yeah. And then we add 4 on both sides. We get y equals -3x plus 7. Right? Yeah. Negative becomes plus. Right. And we add 4. That's why we get 7. Okay. Have a nice weekend. Yeah, don't forget to turn in your homework by midnight in Blackboard. Okay. Start